Okay, so chapter 1, you're going to be going over kinematics, which is basically studying objects in motion. And what you're primarily going to be going over is position, velocity, and acceleration. There are other things that go beyond this, but in Physics 1 you're just going to be going over these three things right here. So these are all related because acceleration is the derivative of velocity, and derivatives are what you're going to be learning in calculus, so I'll explain that to you right now. And velocity is the derivative of position. So what I mean by this is, I'm going to take this for example, x of t. X is your position in the x direction. Now you have your x and your y graph. We're just going to worry about our x position. So x position in relation to time is, we're just going to go with something simple, such as a quadratic equation. B of t plus c. A, b, and c are all constants, and t is your time, and that's a variable. So this is your position. Now, in order to find velocity given your position equation, you take the derivative, which is velocity, and it will look like this. V of t, so velocity in relation to time. So what you're going to do in order to take the derivative is, you see this equation up here, you're going to take this 2, bring it to the front. There's going to be 2 times at, right, because you have that right here, so you bring that down. And now this, you're going to bring it to a lower power. So this is going to be 2 minus 1. So 2 minus 1 plus, and now this b of t, it is the same as if it's raised to the 1 power. So you're going to bring this 1 also to the front. So 1 times b of t. And now you're going to do 1 minus 1, because you have to bring it to a lower power. So 1 minus 1. And then plus your c, it doesn't have any variable. So it's kind of like saying t to the 0 power. And when you bring 0 to the front, it's just 0 times c times t to the negative 1, because you have to subtract 1, right? So 0 times anything is 0. So ultimately, when it's just t left over, it just goes away. I mean, when it's just c, sorry. So what you have left is 2at to the first power plus b. That's what you have left, because 1 minus 1 is t to the 0, and t to the 0 equals 1. Anything to the 0 power is 1. So this is what you have, this is what you have for your v of t. Now, in order to get the acceleration, you're going to take the derivative of velocity, which is acceleration. Acceleration respect to time. So you're going to do the same thing. You're going to bring this 1 to the front. So 1 times 2 at. And now it's going to be 1 minus 1. So it's going to be 0 plus, and then this is b, like I said, this is like t to the 0. So you're going to bring 0, and then it's going to be t to the negative 1. But 0 times anything is 0. So you're going to neglect that. And this is going to equal t to, or a variable to any power, that's always 1. So it's 1 times 2a times 1, which is 2a. So your acceleration is 2a. So you get your acceleration and your velocity from a position equation, but you can also manipulate these. So say if they only gave me velocity, right? So they gave me a 3at squared plus 2, right? And say if I wanted to get position from here, I can do it backwards. This is more of calculus 2, So this might be a little overboard, but you can manipulate the equations so you can go from velocity to position, or position to velocity. You can go back and forth. So if I wanted to do x of t, I would bring this back up. So a of t cubed, but now, yep, that looks about right. And this would be 2 of t. Just raising it. This would be my position. It's kind of useful to know, but you also don't need to know it for physics 1. This is more calculus 2. So it's not necessary, but like I said, it's nice to know. So this is actually integrating. But if you wanted to derive, which is what you're going to be doing most of the time, you're going to do the acceleration. So you're going to take the derivative of this. So I'm going to bring 2 to the front. 2 times 3 at. And I'm going to do 2 minus 1 because I have to bring it down to power. Plus 2. And this is like t to the 0, right? So I'm going to bring 0 to the front. And then I'm going to do t minus 1. But 0 times anything is 0. So you kind of just neglect this part. Whenever it's just a constant, you just neglect it. And then you do 2 times 3 is 6 at to the 1 power. So this is your acceleration in respect to time. So in order to see this as a graph, what it would kind of look like, say this is your x, this is your t. Now this is a position graph. Time. So say your position graph is, say it's a function. I'm going to do this also for simplicity. Your graph looks like this. X of t equals x squared, right? So what x squared typically looks like, this is 1, 1, is like this. Okay, great. So what your velocity will look like, velocity time, so this is your velocity, this is your time, is the derivative of x squared is, you bring 2 to the front, x, 2 minus 1 is 1. So this is 2x to the 1 power. So what does 2x typically look like? This is 1, this is 1, this is 2. So you're going to be, your slope is at 2. So that is what your velocity is going to look like. And then you have your acceleration, time, acceleration, this is your time. Now your acceleration is the derivative of, so this is quadratic, this is linear, and this is going to be constant. The derivative of velocity is acceleration, so we're going to take the derivative of 2x to the first power. So we're going to bring 1 to the front, so it's going to be 1 times 2, which is going to be 2, and it's going to be x to the 0 power, because 1 minus 1 is 0. So anything to the 0 power is 1. So it's literally just going to be 2, and that's it. So you're going to have just a flat line. This is 1, this is 2. You're going to have a flat line coming across like this. So I don't know if you can see how this relates. This is quadratic, so this is x squared. This is linear, so it's 2x. And this is acceleration, and it's constant. So another way, if you have graphs, in order for you to go backwards, for me to get my let me see, my acceleration at time t equals 2, right, at 2 seconds, it would be this area right here. This wouldn't necessarily work with complex problems, but with simple problems like this, it would definitely work. So the area right here would be time 2 times 2, so 4. So my velocity at t equals 2 would be 4. So at t equals 2, my velocity should be at 4. Right here. Right? And I can say that that is true because where t equals 2, I'm at 4. And you can even plug that in case you're not sure. When t equals 2, or when your x in this case, sorry, I put x's here instead of t's, these should all be t's. When your t equals 2, so this is just an example, when you're trying to figure out, what's my velocity? At t equals 2, so right here I'm going to plug in 2. 2 times 2 is 4, so that's correct. Now, in order from go to velocity to position, you would do the same thing. However, this is a triangle, right? So you would do 2 times 4. So I'm going to do this over here. You would do 2 times 4, which is 8, divided by 2, because it's a triangle. So you're not getting the whole box, just half of the box, which would equal 4. So your position at time equals 2 is 4. And you can also check this. Your position would be right here. You can also check this by doing an example or double checking with the equation. So x at t equals 2 would be time is 2 squared, and 2 squared is 4. So these are some basic, these are the basic concepts of position, velocity, acceleration, and how they're related to each other. And yeah, so acceleration is the derivative of velocity, and velocity is the derivative of position. So